Okay, so what we're doing today is talking about matrices, augmented matrices. A matrix is a rectangular arrangement of numbers that are written in rows and columns.
Hunter Barr, come to the office. Hunter Barr, come to the office.
Rows and columns. Now we state the dimensions of a matrix as rows by columns. Now this one here has 2 rows and 3 columns, so we would say 2 by 3, 2x3. Now we always denote matrices. We name the matrix itself by capital letters. Elements, so the numbers in a matrix are called its elements. And if we wanted to talk about the elements of a matrix, we normally reference it as a lowercase letter. So lowercase a, and then we would have row and column. We will get more into elements later on in the year. We will come back to matrices again. There's a lot that we can do with them. We're going to touch briefly on it today and tomorrow, 1-7. And that's about it. So there is more to do with matrices than what we're going to cover. A matrix derived from a system of linear equations, each written in standard form, so x, y, z, x, y, alphabetical order, with variables on the left, what it's equal to, our constant on the right. And taking those and writing them as a matrix is what we call an augmented matrix. You do not have to write this down. Because if we look at this here, the first equation, 5x plus 3y minus 2z, if we took it and wrote it as an augmented matrix, we'd have 5, 3, negative 2, 1. We're taking the coefficients and what it's equal to. So x plus 2y plus 3z equals negative 1. 1, 2, 3, negative 1. 3x minus 4y plus z equals 10. 3, negative 4, 1, 10. If a variable shows up in one of the equations, we have to represent it in all of them. Okay? Let's see what this is or how this actually works. We are given this system of equations here. Y minus 2x equals 1, and x plus 3y equals 12. So we want the variables in the order x, y, z, x, y. Now, both equations have the variables on the left-hand side, so we're good there. However, the top equation, y is first, but we need x to be first, yes? So we're going to take the minus 2x, negative 2x, and we're going to move it to the front. The positive 1y plus y equals 1. Because x and y are already on the same side, we can just switch the order. Because it's minus 2x, it's going to be negative 2x. We keep the sign with it. Questions on what we did or how we rewrote this? Let's write the augmented matrix. I normally write one of the brackets. I don't write both, mainly so I have it spaced out enough. Going across the top row, what's our number for x? Negative 2, because it's the number in front of x, yes? What's the number in front of y? Yeah, the top one. So we have 1y, and it's equal to? So the first row is negative 2, 1, 1. Now I put the other bracket because I've kind of spaced out the first row. All the rows are going to be matching in length. So we have that there. Questions on the first row? What would the second row be? X would be 1. Y would be equals 12. So 1, 3, 12. Questions on this here? Dimensions. How many rows do we have? 2. How many columns? 3. 3 by 3, because we go 2 down, 3 over, it's a 2 by 3. When I'm looking at dimensions, I always start in that top left corner. I've got 2 going down, 3 going across, so it's 2 by 3. Questions on this here? We ready for the next one? All it asked was us to write the augmented matrix. We did, and state the dimensions. 3y plus 4x equals 13. 2x minus y equals 5. The second equation, we do have it in the form of x, y, yes? Do we have it in the top one? No, so we can just rewrite it as what? 4x plus 3y equals. We normally want it x, y, z. We want it alphabetical. Because the main thing is we want them to match up and be the same. And we do x, y, z because that's just standard form according to number theory. We always do alphabetical order. Because we could do y, z, but we would have to know, or they would have to know that that's kind of the setup. Because if they had the equations, 3y plus 4x equals 13, 2x minus y equals 5, and they saw, okay, we put the y's first, it makes sense. If we're not given the equations, we would just default to x being first. And if we put y first, it's now been flipped. So then we'll reassociate. Does that make sense? All right. Any other questions? Did we necessarily have to rewrite the equation out for the first one? No, because x is what? 4, y is equals 13. So 4, 3, 13, yes? Second row. 2, -1, 5. Because if we saw that x is 4, y is 3, we could just go 4, 3, 13. We don't necessarily have to rewrite it. If rewriting it helps make sure you get the correct number and sign, rewrite it. Dimensions. It is by 3, because we have 2 rows and 3 columns. It is possible to have a 1 by 4, 1 row, 4 columns. It's possible to have a 1 by 1, 2 by 2, 4 by 4. We can have any size matrices we want. For systems of equations, the number of rows is going to be less than the number of columns. Questions on this here? This time we have 3 equations. The second equation, we do have all the variables on the left-hand side, number on the right. And that one's in alphabetical order. The third equation, we do have all 3 variables on the left-hand side. X, Y, Z, they are in alphabetical order, yes? I skipped the first equation on purpose. Do we have all the variables on the left-hand side? No, we have Z on the right-hand side, yes? So, let's pull it over here. We have to move that Z from the right-hand side to the left, from the right side of the equal sign to the left. How can we do that? We can add 2Z to both sides. We can just add something to both sides. Because if I add 2Z to the right-hand side, negative 2Z plus 2Z, negative 2 plus 2 is 0. So that will leave us with 7, our constant term on the right-hand side. On the left-hand side, x, y, and z are not like terms. So we have 3x minus 4y plus 2z. I'm just putting it back up above it just so we have all 3 kind of next to each other. No real other reason besides that. It's just kind of nice to have them all 3 there. Questions on how we got x, y, and z on the same side? All right. First row is going to be what? 3, negative 4, 2, and 7. 3 for x, negative 4 for y, 2 for z, and then it equals 7, yes? Middle row, what's our x? 9, what's our y? What's our z? Equals, because the other 2 equations had z, the middle one has to have z also. If it shows up in one, it has to be in all of them. We didn't include z on the last 2 because it did not have z in either equation. If it's not included in any of them, we're not adding it in. But because the top equation had a z variable, the middle one has to have it. Even if the bottom one didn't have z, it has to have it too. If one of them has it, all of them have to have it. We're just saying we have 0 z's in the middle equation. Bottom equation would be 2 for x, 4 for y, -1 for z, and 2. What are the dimensions? 3 by 4. 3 rows, 4 columns. 3. Question? Yeah. You're good. 3 by 4. I always start in the top left, see how many I go down, because that gives me the first one. 3. How many can I go over 4? We would need, yeah, one more set. But yeah, I can see. Questions on this here? You ready for the next one? Looking at these 3 equations, are all the variables on the left-hand side? Are they all in alphabetical order? Well, we can just straight write the equations. We don't have to do anything to them. Good. All right. Top row will be what? 8. -3. 1. 5. Second row. 2. 1. 4. 2. Last row. 9. -7. -3 and -6. Dimensions. 3 by 4. Questions on these here? Do we need to see another example of writing an augmented matrix? Are you ready for the next piece? Next thing we're going to do today. So the only other thing we're doing today, I think we're going to be good with, but you're going to be frustrated with it at the same time. All students are frustrated with it, not so much in and of itself, but you'll see here in a bit. Solving the systems of an equation using technology. Using these augmented matrices, we can solve systems of equations. Now, as we look at this first piece here, we are given this matrix, that we have this diagonal of 1s and all 0s. And as we've been plugging these in to get the system of this augmented matrix, the first column was our x values. Second column was our y values. Third column was z. So if we rewrite the top row, we would say that we have 1x plus 0y plus 0z is equal to -1.4. That's all the top row says, yes? Well, 0y and 0z, really what this is saying is what x is. X is -1.4. The middle row, we have 0x plus 1y plus 0z is equal to 5.2. Well, that's just saying what? Y is equal to 5.2. We don't care about 0x or 0z. Last row, 0x plus 0y plus 0z, or not 0z, 1z, z is 16. We're just saying z is. So really that last column, top to bottom, x, y, z. That's why we order the variables when we plug them in, x, y, z. So it tells me what it is in that last column. Only thing we have to, and we'll cover that here in a bit. But questions on kind of what this reads? We kind of good here? Now, solving a linear system using technology, we write the matrix or write an augmented matrix for the system. We enter it into our graphing calculator. We do use something called reduced row epsilon form, and then interpret the information. So the next one here, I did include the pictures of what the graphing calculator looks like on your note sheet. That's what all those 4 little squares are. Now the first thing we need to do for this is write the augmented matrix for this system. Now if we look at the first row, we have x plus y plus z equals 2. So the first row would be 1, 1, 1, 2. Second row, 2, 3, 1, 3. Last row, 1, -1, -2, and -6. The dimensions are what? 3 by 4. Okay. We good on how we got the augmented matrix and the dimensions, yes? Next thing you need to do, yes, sir. Yes. Yeah. Help you count them. Any other questions? First, so the next step is to turn the graphing calculator on. I will try to make sure to remember to clear this out so it does show the key press history. So anything in that is when I type a button, it will show it back up. And once we get them turned on, the first thing we're going to do is second matrix, second x to the -1. We should get something that looks like this here. Second matrix, second x to the -1. Yep, got it? So if you notice, I will say the same thing twice, because one, I will say what we're doing. So second matrix, second, and then matrix is what we're activating. Second x to the -1. If you notice, the button is actually x to the -1. I will repeat some of those a few times over. Next thing we're going to do is we need to put this matrix into the calculator. We need to go over to edit. So we're going to use the arrow keys, and we're going to go over twice. So edit on top should go inverted, so it should be white text in a black box. And we have a set of matrices A through I showing up. You may have numbers next to it, you may not. We want to pick one of these to plug it in. For the most part, since we're only going to be working with one at a time, we'll just pick the top one, A. So just hit enter to select matrix A. So we have matrix A, we have something like this here. It might not look exact, but probably close. Now your cursor should be up at the top, yes? Matrix A, and then we've got 2 numbers. What that's asking for is the dimensions of this matrix. So the one we're typing in is a 3 by 4, yes? So what we can do is hit 3, enter, 4, enter. We don't have to remove or delete the previous number. Once we start typing numbers in, it's going to overwrite it. So we should have our cursor in the first top left of the matrix, yes? So we're going to type that matrix in. Hit 3, enter, enter. There you go. So the first number we should have is 1, 1, 1, 2. So I'm going to type 1, enter, 1, enter, 1, enter, 2. If you notice, I'm not having to delete the previous number. I'm just typing the new ones in. It will replace it. Then we're going to type the rest of it. 2, 3, 1, 3. 1, -1, -2, -6. So we want to type that whole augmented matrix in. Once you get it typed in, get the whole thing typed in, second quit, second mode. Second quit, second mode. Should be up there at the top. Once you get it all typed in. Once you get the whole matrix typed in, second quit, second mode, we should get back to the home screen where we can type most calculations up there. Is everybody able to get it all typed in? Second quit. Once you get it all typed in, quit, second mode. Yep. So it should go away. Should go away. Because what we're going to do next, I'm going to show you kind of why we do this. So I'm not going to hit it. So what we're going to do next is we need to actually get the reduced row epsilon form, RREF. Now to get that, we're going to go second matrix and over 1 to math. Second matrix over 1 to math. We want to find RREF. It is in there somewhere. You got to go up or down. Okay. Now, since you hit -6, it's looking for a number in front of it to subtract 6 from.
Okay.
We need negative. Yep. Yep.
Alright, is this looking good?
So, -6. Let's see here. Okay, so 1, 1, 1, 2, 2, 3, 1, 3, 1, -1, -2. You just got one number off.
Alright, thank you.
Second quit, second matrix, we're going there. Now find RREF going up or down. Once you find it and have it selected, so we have the letter next to it highlighted. Kind of like that there, so it should be white letter, so white letter in black. Hit enter. Yours should not look like mine at the moment. But you should have that RREF, there's nothing after it, yes? Now I did this on purpose because I did not hit second quit. So what the calculator is saying, do you want to put this function into the matrix? So the reason we go second quit is to get back to the home screen so that matrix been saved, we can now actually start plugging functions in. Now we have this here, yes? Don't press enter, but if we did, it will throw up an error because it's wanting to apply this function, this reduced row epsilon form, to a matrix. We have not told it what matrix to apply it to. So it has nothing to apply it to. It's going to freak out. So we need to give it a matrix to apply this to. So we're going to go second matrix one more time. So this here, the names, these are the matrices we've put into that calculator. We've put the new one we wanted to use, and we're solving for in matrix A, yes? It's been selected, so hit enter. So we should have RREF, and then matrix A. Everybody looks like that there. Hit enter. So we get something like that there. Let's see. Matrix. 1, 1, 2, 2, 3, 1, 3, 1, -1, -2.
Because you guys did it.
Yeah, if we clear it up, that's fine. Second matrix. 3 by 4, 1, 1. Okay. So second matrix, RREF, second matrix A. Yeah. So this is our answer. That is the matrix we put in. So, let's see. 1, 1, 2, 2, 3, 1, 3, 1, -1, -2, -6. So you had that one negative where it should be.
Yeah, it's just kind of saving it as a file. There we
And, yep, negative 1, 1, 2. Did we all get that exact screen? Let's see. Second matrix, edit. So 1, 1, 1, 2, 2, 3, 1, 3, 1, negative 1, negative 2, negative 6. So we need that last one. Yep. So we were able to get this here. We're able to get this here. So that tells me top letter number is X, middle is Y, bottom is Z in that last column. Negative 1, 1, 2. So the solution to the system of equation is negative 1, 1, 2.
Say it one more time.
Because
Smart kid.
yeah, so looking at the top, because it's X is X, Y, Z, because how we did it just a minute ago. Yeah, that's it. So negative 1, 1, 2. So we kind of get how we got here. We can also say this is kind of frustrating because the last 2 days. And this does it immediately, yes? All right. Those are the steps. Let's look at another one. So I'm going to still go at about the same pace I am going. If you want to get ahead of me, go for it. So looking at this here, we do have X, Y, Z. Yep. So we need to write the augmented matrix first. So going across the top row, we would have 2, 3, negative 1, 15. Second row would be 3, negative 9, 9, negative 12. And the last row would be 4, negative 3, negative 1, and 19. This is still a 3 by 4. ACT, yes. First thing we want to do, once we get the augmented matrix written, is we're going to go second matrix, over to edit, and we want to select the first matrix to plug it in. It is still a 3 by 4. This time we have 2, 3, negative 1, 15, 3, negative 9, 9, negative 12, 4, negative 3, negative 1, 19. Let's see. So,
Wait, we gotta edit.
so since you hit -9, it needs to be -9. So you cannot put a minus or plus in the matrix because what the calculator is going to try to do, so -9 is going to say we're trying to subtract something from 9 or 9 from something, and because there is no number in front of it, it can't figure out what you're trying to do. So we say do negative instead of minus. Yep. Negative 119. Once we get it typed in, second quit, second matrix. We go over to math and find our REF. Second matrix, A. So second matrix, go over to edit. Let's see what the matrix is. Let's see.
Really wrong. I got big decimals.
3 by 4. So we have 2, 3, negative 1, 15. 3, negative 9, 9, negative 12, 4, negative 3, negative 1.
Negative. Here we go. Is it just regular 19? Oh, it is. I don't know why I had it. Oh, it's because I was looking. So I'm trying to work on number 11 here,
Mm-hmm.
and somehow I got this result.
Yeah. We'll get there. We'll get there. Any other questions on this one here? Stuck? Yeah. Sweet.
I got an error before I was finished.
So go to, hit enter. So you're doing minus 12.
Oh, not negative?
Yep. Because if you put minus a number, the calculator is looking for a number to subtract it from. So it will actually do function operations in the matricing. Because you say minus 12, it's looking for something to subtract 12 from. Since there's nothing there, it has a syntax error to nothing is being subtracted. Questions on how we got 5, 1, negative 2?
Then how do I get out of here?
Second quit, second mode. Second quit, second mode. Mode. Second matrix. Second matrix. Second. 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 Matrix. Over to math. Find RREF. Second matrix A. Questions on this here?
Yes.
Do we need to see another one of these here? We feel good with these here? I think just doing more practice get there. Now, if A, B, C, 8, E, F, G. Now, A, B, C, I just put those letters in just so we kind of have spot holders. But if that bottom row is all zeros, well, the first 3 zeros represent X, Y, and Z. So what that's telling us in equation form is 0 is equal to 0. Infinitely many. So if we get that bottom row of all zeros, it's telling us that there's infinitely many solutions. That's what all the zeros mean. This one, we do get 3 zeros, yes? So that tells us X, Y, Z, the left side of the equation is 0. And at this time, it's set equal to, is 0 equal to 4? So this would be, does that kind of make sense what we get? It is possible to get decimals. Y'all seen that already, yes? Math, enter. So I'm going to mess with one of these because it should be not too hard to get. Let's see here. I think I'm changing that. Math. If you notice the first one, FRAC, fraction. If I select it and say enter, it will convert those decimals to fractions. One of them might, on the homework, might be fractions. But if we feel comfortable with this here, three through 8, 11 and 12, and 13 through 19 odd. 3 through 8, write the matrix in augmented, or write the augmented matrix, write the system of equation in matrix form. 11 and 12 is find the mistake and correct it. So say what they did wrong and fix it. They most likely put a number in the wrong space in writing the augmented matrix. So you're using the same three equations for both 11 and 12. 13, 15, 17, and 19, you are solving those systems. We have about 6 minutes or so before the bell. If you want, you could probably get most of the solving done before then, but you have the rest of the time to work on this.